We're first going to pick up where we left off yesterday. We were evaluating these logarithms, so I asked you to go ahead and finish these, and then we'd talk our way through them. So on number 16, I have first I'm going to set it equal to x. So I can do 49 to the x power equals 1/7. And then I have a couple of options on which base I could use, so I'm going to do it two different ways. I could use 7 as my base. So 7 squared is 49, so that's 7 to the 2x power, don't forget that x, is equal to 7 to what power? -1. So that means that 2x equals -1, so x equals -1/2. Now, I would imagine that probably most of you use 7 as the base, but I could have instead used 1/7 as the base. So if I did that, I'd have 1/7, and then to get to 49, that'd be to the -2 power, so it'd be -2x equals 1/7 to the first. So then I'd have -2x equals 1, and I'd still end up with -1/2. So it doesn't matter either way, right? One way is not better than the other. It's just whatever makes sense to you at the time. All right, so number 17, I've got set that equal to x. So this will give me 32 to the x power equals 2. Don't really have options here. I think 2 is going to have to be my base. So 2 times 2 is 4, 8, 16, 32. So that's to the 5th. So I have 2 to the 5x power equals 2 to the 1st. So 5x equals 1, and x equals 1/5. Okay, we good? All right. Then here, I'm going to set this equal to x. I'm going to get 1/4 to the x power equals 64. What did you use as the base? 4. Okay, go with 4. So this would be 4 to the -x power equals 4, and then 4 times 4 is 16, times 4 is 64, so that's the third. So I get -x equals 3, which means x equals -3. Now, you could have used 2 as the base. When I made the key, for some reason, I used 2 as the base, but it doesn't really matter. So that gave me -2x equals 6. I still got x equals -3. Doesn't matter either way. Okay? And then as a reminder, here, I didn't necessarily have to go through this to get to this, because one of the rules on that little reference sheet I told you to have handy says log base anything of 1 has to be 0, and then this would be the process to get there. So that's this right here. Log base b could be any real number, equals 1. I'm sorry, log base b of 1 has to equal 0. And log base b of b is 1. So log base 8 of 8 is 1. Log base 20 of 20 is 1. Okay, but if you didn't know the rule, you would do 8 to the x power equals 8, and clearly it's 1. You still figure it out. Okay, all right, so have this handy so you can look at it, and let's expand and condense some of these. We're going to use these properties. So we're expanding it and condensing. We're not solving anything so that we can then get to actually solving equations, but we got to be able to get through this first. Okay, so I have 2 logs that are being subtracted. I can condense that into 1 log that is just has division, but I can't do that yet because that has to be just in log form, and I have this 2 out here. So this 2 that's out front, I can put it inside my log as a what? Square. It becomes an exponent on whatever that argument is right there, which is 6. So this is log of 6 squared minus log of 9. And it would be fine to put 36 right there and skip that step, but I don't want to lose anybody early on here. So that gives me then log of 36 minus log of 9. So now that I have that, I just have a log and a log, subtract. It condenses into 1 log, and I divide the 2 arguments here, 36 and 9, which gives me the log of 4. What's the base of this log? 10, exactly. What questions you got? We good on that? See how that process works? Ask me a question. Daisy, ask me a question. No, I'm good. No, ask me a question. Okay, lying to me, but whatever. All right, so now when I look at number 2, again, I'm adding. So when I condense it into 1, it's going to become not addition, but what? Multiplication. But I got to take care of the exponents first, right? So that I start with just the log. So this will be log base 4 of a to the 4th plus log base 4 of b squared. example of when you have variables, sometimes there's less steps and it's simpler because you can't actually take a to the fourth like we could take 6 squared here. I just have to put it in there like that. So I'm adding, it condenses into 1 log with the same base, because so these have to have the same base. Log base 4 of a to the fourth b squared. And that's all we can do. That's it. Everybody good with that? All right, then you do number 3. Thank you. All right, so this is what you should end up with. Notice that that is v to the 6th, not v to the 5th, because when you take this exponent up here and you end up with that b squared to the 3rd, your power to a power rule is that you multiply. Okay, we good on that? All right, so let's look at number 4. Number 4, we got 3 things, and your order of operations rules, you just do addition and subtraction in the order you see it from left to right. So we're going to take care of these 2 here first. So this is going to give me log base 2 of 15 times 4 minus log base 2 of 6. What's 15 times 4? 60. So log base 2 of 60 minus log base 2 of 6. That subtraction, I condense it into 1, and it's 60 over 6. So that gives me log base 2 of 10. Now, when you're actually doing this, there's a couple of steps you could skip. I don't think it's a good idea to skip them on your notes, because sometimes if it's been a while and you go back, you wonder where the heck the numbers came from. But it's fine to start to just go ahead and make that 60 when you do it, and when you know you divide to get to 10. We got to show some work, but you don't necessarily have to write down everything every time you do it. But I want to show you, now 4 times 15 is not that big of a deal. These numbers aren't that bad. But let's say that these numbers were a lot bigger, a lot worse, and you just don't want to have to think through it. Let me show you how else you could have handled it just on a number sense track here. So if I have log base 2, instead of 60, I'm going to leave it as 15 times 4, and I'm going to divide it by 6. Okay. Now on this one, I think it's totally easier to do it like we did, but I just want to show you how you could do it and it may be easier on a different problem. So now that I have this, I basically just have to simplify this fraction. So instead of actually multiplying this and getting a bigger number, I can divide both of these by 2, so I get 2 and 3, and then 3 goes into 3 once, into 15 5 times, so I end up with 5 times 2, and I still get log base 2 of 10. Okay, so it's just about manipulating the numbers to maybe make things a little easier for you when it's like not a calculator thing. I would still get log base 2 of 10. Right, so just make sure you know how to work the numbers in your brain. Okay, let's look at number 5. I've got 3 things again. If I was going to do it one step at a time, what do you think my first step should probably be? What should I take care of first? The exponent. That would be my suggestion. This 1/2 coming up here, and it becomes an exponent, right? And then I also need to combine these. So I can do more than one thing in a step. I'll go ahead and combine these and take care of the exponent on that one kind of all in one. So this would give me log base 3 of 4y plus, so when this comes up here as a 1/2, what's 49 to the 1/2 power? 7, so this is log base 3 of 7. Then I'm adding 2 logs with the same base. I condense it into a single log, and I multiply the 2 arguments, and it gets me 28y. Turn that off, please. All right, number 6. I have a couple of different options as to how I could start this. So let's talk about one, and then we're going to probably back up and do it a different way. So order of operations says that I should probably take care of that first. So if I did that, I'd get 1/3 times log base 5 of whatever 8 times 27 is, which is not crazy difficult, but let's say that, yuck, we don't even want to try and possibly mess that up, okay? It's not impossible, it's 216, but whatever. So once I get that, then I'm going to have to take this 1/3, and that means I'd have to take the cube root of that number, right? And the cube root of 216 is not that bad either. It's actually one you should know. But I don't have to do it that way. Again, like what if those numbers were bigger and they were yuckier and it was a cube root I didn't know and then I had to go figure out. Another way you could start this, which would reduce the numbers along the way, is, and again, this is not wrong, there's absolutely nothing wrong with that, but instead of doing that, we could go ahead and just distribute this 1/3. And I could get 1/3 times log base 5 of 8 plus 1/3 times log base 5 of 27 minus log base 5 of 3. You with me? So now I would take care of that exponent, and then, so that 1/3 comes up here. That means I want the cube root of 8. What's the cube root of 8? 2. Okay? Plus, then I need the cube root of 27. What's that? 3. Minus log base 5 of 3. And because I left it split up, look at what happens. These two zero out, and my answer is log base 5 of 2. Had we gone with this version, our steps along the way would look different, but we'd have the same answer in the end. So it really doesn't matter. I just want you to see that there is more than one way to approach these sometimes. Okay, we good? All right, then you go ahead and you do number 7. What should my final answer be? 1. Log base 2 of 2 is 1. Log base b of b is 1. Log base monkey of a monkey is 1. Doesn't matter what it is. Okay. So if you got to here, you're not wrong. You're just not finished. As far as cubing this number, 4 cubed, again, not a big deal. You should totally be able to do it. But what if it was like 32 cubed or something like that? Another way to look at this is I could leave that, like I know it's 4 cubed, so especially if the numbers were bigger, I could have log base 2 of, and then I could have 4 times 4 times 4 over 32. And since I'm going to need to reduce, I don't really care what 4 cubed is as long as I can handle this. So 4 goes into 4 once, into this 8 times, and then I can take another 4 and make that a 2, and then 4 over 2 is 2. Okay, so just a little number sense there. Again, I would think in this case, this way is easier, but there are other ways to manipulate your numbers. Okay, all right, so let's do number 8 together. I'm going to take care of my exponents first. So this is going to give me the natural log of 6 squared, which I'll go ahead and make that 36, minus, then I'm going to take 16 to the 1/4 power. What's another way to say that? The 4th root? It's the 4th root. Okay. So taking the 4th root of something is actually very easy. You know, like if you're going to divide by 4, you can divide by 2 and divide by 2 again. Like that's an easy way to kind of knock it down. The 4th root, all you have to do is take the square root, take the square root again. So the square root of 16 is 4. The square root of 4 is 2. And then I have plus the natural log of 3. So then natural log, I'm going to do these two first. What's 36 divided by 2? 18 plus the natural log of 3. Then the natural log of 18 times 3. What's 18 times 3? 54. Good. Okay. So I asked a couple people last year, I was like, okay, how do you get, what happened in your head when you did 54? So one person told me they did like the 3 times the 8, they carried the 2, and like basically they did what you were taught in elementary school, they just did it in their head. So I said, that's perfectly fine. If that works for you, that's one way to do it. I don't carry things in my head, because if I do, they'll get lost in my head. Like that carrying is not a good idea without me writing it down, okay? But again, you do use however your brain works. Another person said basically what I would do would be 3 times 10 is 30, 3 times 8 is 24, then you got the 30 and the 24. Did anybody do 3 times 20 and then subtract 6? Okay, 3 times 15. Okay, that's good. And then 3 times 3, that works too. See, there's all different ways, and it's whatever makes the most sense to you as long as it's legal. I personally, and then again, this is just me because it depends on how your brain works. Sometimes I do that subtraction method, but most of the time I don't, because I feel like I have to think too hard about what I'm subtracting, because I guess probably because I don't do it a lot. But if you've done that a ton, like that's a lot faster for you. So you just figure out what works for your brain and you're good. Okay, or write it all down, that's fine too, but you don't always have to do all that. We good? Any questions? All right, so that's condensing. Now we put them together, now we're gonna take them apart. Okay, we're gonna expand. So this says we've got log base 6 of x times y times z to the 4th. All right, so I can't take care of my exponent first because that 4th is not on the whole thing, it's only on the z. But I have these 3 things being multiplied together, so I can split them up into what? Addition. So this will give me 3 separate logs with addition. So log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th. You could go ahead and pull out the 4, it's fine. I'm not going to do that on the notes here just because I don't want to lose anybody. And then this would be log base 6 of x plus log base 6 of y plus 4, because this has to come down in front here. Not in front of the whole thing, just in front of that log base 6 of z. Yes? We agree with that? Awesome. All right, so then I have a log, I have division, and I can split that up into subtraction. So this would give me log base 4 of a to the 9th minus log base 4 of b. Then to expand it even more, I have to make sure I take care of that 9. So that's 9 times log base 4 of a minus log base 4 of b. What questions do you have? Awesome. All right, so now let's look at number 11. Now, one of the differences between 11 and 9 is that here, the parentheses, I didn't really even need them, but here this squared is on the whole thing. I have 2 options. I can go ahead and distribute that 2 to the other exponents. That's not my favorite way, I would suggest, because then there's whole kinds of room for error. But I can go ahead and bring it out in front here. So I'd have 2 times log base 7 of q to the 4th r squared. Now I can take this part and split it up, but that 2 gets multiplied by the whole thing. And since I'm taking one thing and splitting it into 2, I need to make sure I have parentheses here. This will be log base 7 of q to the 4th plus log base 7 of r squared. Bring my exponents down, so I get 2 times 4 times log base 7 of q plus 2 times log base 7 of r. Then my last step is to distribute, and yes, I have to distribute because I'm expanding it completely. Log base 7 of q plus 4 times log base 7 of r. Okay. What questions do you have? All right, so I was going to have you stop and do one, but just because of time, I think I'm going to go ahead and we'll just work the rest of these together. So on number 12, I bring the 2 out in front first. So it's going to give me 2 times log base 2 of y over z to the 5th. I have 1 log that has division. I can change that into 2 logs with subtraction, but once again, you got to be careful with those parentheses. So log base 2 of y minus log base 2 of z to the 5th. Take care of my exponents, so I get 2 times log base 2 of y minus 5 times log base 2 of z. And then I need to distribute that 2. So it gives me 2 times log base 2 of y minus 5 times log base 2 of z. Oh, not 5, dang it. Maybe we shouldn't do these together. Might be better off on your own. 10, make sure you actually distribute and don't just pretend to distribute. Okay. We good? Awesome. All right, so let's check out 13. So this square root, I'm going to have to change to an exponent. So this is going to give me natural log of parentheses 7x cubed to the what power? 1/2. Okay, and those parentheses are important because that was all inside that square root. So then I can bring the exponent out front, 1/2 natural log of 7x cubed. Then I'm going to split this up. So I need parentheses, 1/2 times natural log of 7 plus the natural log of x cubed. Take care of my exponents. So just rewrite all that first part, and then that gives me 3 natural log of x. Then I distribute 1/2 natural log of 7 plus 3/2 natural log of x. Oh, we still have like 5 minutes. So any questions at this point? All right, so then you go ahead and do 14 on your own, and I will do it up here, and we will make sure that we agree. So when you're done, double check yourself with me. Make sure that we agree. Ask me questions if you have them. Your assignment today is in Delta Math. Right? You use a little reference sheet if you need to. And again, we're doing this so that we can get to the part where we actually solve stuff. So we good? Any questions? Awesome.